Hi everyone, thank you for looking at this new video. In this one, I want to talk about a processor that we have in NiFi, allowing you to push data into Delta Lake tables. Delta Lake is a format table that is pushed and created by Databricks, and I want to show you how you can use this processor to push data into such tables. So I have my NiFi cluster, and I have an NiFi flow here. I'm going to go through all of this and explain how it's working. And then on this side, I have Databricks cluster running on AWS, where I'm going to run some queries to check the data and so on. So the first thing I did, you can see it here, is to drop the table that I'm going to use. You can see there is no table. So I will be creating a table and pushing data into that table. So let's create the table here. You can see it's a basic table, but something important to notice is that the table is partitioned by the column CRAD. So that's something that will be useful because you want to make sure that the data you are pushing is partitioned by the column you specified here. So I will open the table in the Catalog Explorer on the Databricks side because it's going to give me some useful information about the table, especially the table ID that I need in my flow definition. So I created the table on the Databricks side. That's great. If I try to select what's available in this table, there won't be any record, as you can see. So I can go ahead, go into my NiFi flow and look how it's working. So it's very straightforward. My use case is I have a bucket where files are landing. I want to get this data as soon as the files are available, and I want to push the data into my destination table to make it available for queries, okay? So the first step is really just list S3, fetch S3. So I'm just, as soon as there is a new file pushed into my input bucket, the processor will list the file, then I'm fetching the file so that the file is retrieved in NiFi. So really just basic steps here. Then the next step is to partition record. The reason is that for a given file that I receive, maybe within that file, multiple records will go into different partitions. And if that's the case, I need to have different files because in the object store that is underneath the table, I need to have files dedicated to each partition. So that's what I'm doing here with the partition record processor. So in this processor, I'm using a CSV reader because I'm assuming that the data I'm receiving is CSV, and I'm using Parquet as the writer because that's the default format for Delta Lake tables. So I want to use Parquet for writing the files. And then I specify the partition column here. So I use the parameter, but this is the CRAD column. So if I look into the parameters here, this is the CRAD column, and I'm specifying the schema here where I have all of my schema with all of my columns from the CSV file. And I also have an output schema where I'm just removing the CRAD column because since each file is going into a dedicated file for the partition, we don't need to keep this information because all of the records would have the same value. So the value of the CRAD column would actually be in the file structure. I will show you in a minute. The other things are straightforward parameters, the input bucket, prefix for fetching files in a specific location of my input bucket. There is the bucket for my Databricks deployment, and then there is the path of the table. And actually, I'm going to update this because I created a new table. So I need to update the path because the table ID changed. So here I'm going to change this with the new table ID. And that's it. Then once my files are partitioned, I'm sending the files into the right location. So you can see here the path to the table, and then I'm specifying the partition column equal the value for this partition column for the files that I'm pushing. So this is a flow file attribute that has been created by the partition record processor. And then I'm using the UUID attribute of the flow file to make sure the file name is unique. So that's it. And then I'm calling the UpdateDeltaLakeTable, where this is using the Hadoop client in the backend. The reason we are using the Hadoop clients in this processor is because this way you are completely cloud agnostic. So you could run this, the same flow definition on any cloud provider. So that's the approach we are taking here. Actually, here I'm using S3 processors, but we have Cloudera processors that are completely cloud agnostic, the CDP object store processors. So I could actually replace all of this by the CDP object store processors so that really the exact same flow definition could be deployed on any cloud provider. So here, the processor is really straightforward in terms of configuration. I'm giving the path to the table into S3, and then the path of the file I just pushed so that I can update the Delta Lake metadata for that file so that I can query the data that I just pushed. So that's it. That's how it's working. I'm going to stop the processor to show you step by step how things are working. If I go here and I go to my table, if I recall correctly, that's the one. So we can see there is nothing here in S3. There is just the metadata folder with the delta log files. But for now, there is nothing. So I will stop this. I will clean the state so that I'm removing here. And the file I'm going to send as a first step is this file where I just have 3 records, but spanning across 2 partitions. And that's what I want to use right now. So a very simple file, but then we will push a bigger file. So I'm starting this. The file has been retrieved. So if I look at the file here, I have the 3 lines I was talking about with my CSV data. And then if I start the partition record processor, I have my 2 flow files that have been created because 2 partitions. So it's been split into 2 different files. I can't open the file and show you what's inside because this is using Parquet. So like if you try to look at it, this is not looking good. You can see if like this is binary data and you have some data in it, okay? So that's it. Then I'm pushing the files into S3. So now if I look here, the files are here now. I have my 2 directories, 1 per partition value for the partition column grad. And in each folder, I have my file that I just pushed. Sorry, here and here. But if I stop here, this is not enough, because if I look at what's in my table, even though the files are here, you can see the table is showing empty. So I really need to update the delta metadata for this table. So that's what this processor is doing. Now the flow files are here. The flow fully executed successfully. And now if I run the same query again, I will see now the 3 records that I just pushed into my table. So let's wait a few seconds just to see that I have my 3 records. Here you go. So the data is now available, okay? So that's it. Now I'm going to go one step further, and I'm going to ingest an additional file where I have 100,000 records with random data. For the partition column, the values are going from 1990 to 2023. And it's random data that I generated. There is 100,000 records, just to show you how it looks with bigger files. So I'm going to push that file into the input directory here. So I will just give me a second here. Where is the file? It's here. Okay, so 100,000 students and upload. So the file is being uploaded here. I'm going to stop here so that we can see what's happening. So as soon as the file is landing here, so we have it here. So the file is going to be ingested here. My list S3 processor is running once every minute here. So just I can stop it and restart it so that we don't have to wait. The file has been retrieved a bit below 5 meg. This is partitioning the data. Now we have 34 files, 1 file per partition. I'm going to push the data into S3. So the data has been pushed. If I go back to here and I refresh, we can see that I have 1 directory per partition. If I go to the folder that I had before, we can see that now I have 2 files instead of 1. And I can start this processor to update the metadata around my table. So all of this is running. It's taking a few seconds to complete everything. Here we go. And if I go back here and run the query again, we have to wait a few seconds, but this time we will see a lot of records. It's by default, it's limited to 1,000. So we can see here some records. If I do a count, we have the number that we are expecting. So 100,003, the first file and the second file. So that's what we want. And if we look at how many different values we have for the partition column, this is 34. So that's what we want from 1990 to 2023. So that's how you push your data efficiently into Databricks using the Delta Lake format for your tables. Here I'm using a flow that is running in NiFi, but obviously you could use the exact same approach using Cloudera DataFlow functions so that you can run this embedded into AWS Lambda or Azure functions or Google Cloud functions with the associated object store trigger. So for example, I could run this as a function triggered by S3 files landing, and that will start an AWS Lambda function that will be running this code so that NiFi is never running 24/7, but your function is just running when there is a file to ingest. Last week or 2 weeks ago, I published a video where I'm doing something very, very similar, where I'm using the trigger HMS processor, and there is also another one where I'm using the put iceberg processor, which is very similar to what we are seeing here. So if you want to see how you can run this flow as a function in AWS Lambda, for example, or Azure functions, whatever, you can have a look at those videos because the approach will be very, very similar. So that's it. Hopefully this was useful to show you how easy and straightforward and efficient it is to push data into Databricks and use the Delta Lake format table. So that's all for this video. As always, feel free to ask questions in the comments, make feedback about what you would like to see next. And thank you again for watching this video. See you next time.